Today, we're diving into some groundbreaking advancements in AI, from NVIDIA's unified audio text models to revolutionary changes in software development environments. Prepare to explore how these innovations are reshaping industries, enhancing productivity, and posing new challenges. Let's get started. NVIDIA recently unveiled Audex, a unified audio text large language model designed to revolutionize multimodal integration in AI. This model, known as Nemotron Labs Audex 30B A3B, builds on the text intelligence of its predecessor, Nemotron Cascade 230B A3B, by seamlessly incorporating audio capabilities. Audex employs a single transformer decoder architecture that allows audio inputs to be encoded and projected into the text embedding space. Such a structure marks a significant step forward for creating systems that can handle both text and audio input in a cohesive manner. Among its key features are the utilization of 157.4 billion audio tokens and 320.5 billion text tokens during training, highlighting its extensive multimodal learning. The technical components include a unified architecture, integrating audio and text capabilities in one transformer decoder, audio inputs that undergo encoding into a text-like embedding space, training processes that encompass multi-stage supervised learning, cascade reinforcement learning for text, and on-policy distillation across various domains. In terms of performance, NVIDIA claims state-of-the-art capabilities in audio understanding and speech recognition, though specific benchmarks have not been disclosed. However, the backbone model reportedly experiences minimal degradation in performance. Yet, Audex is not without its limitations. The lack of detailed performance metrics and resource requirements for deployment raises questions about its scalability. Additionally, there are concerns about potential contextual limitations in complex audio scenarios and inherent biases from training datasets. Curious to see Audex in action? You can. Explore the model on huggingface.co/NVIDIA Nemotron-Labs Audex 30B A3B. Review the full research paper on http://2607-05196. Check NVIDIA's developer.nvidia.com NVIDIA IMS Nemotron Audex source OpenEye for integration insights. In a nutshell, Audex represents a leap forward in integrating audio and text processing, promising new efficiencies in interactive systems and content creation. It positions NVIDIA at the forefront of multimodal AI development, paving the way for future innovations. Ant Group's AI subsidiary, Ant, has recently open-sourced LingBot-Vision, a novel vision transformer model specifically designed for dense spatial perception tasks. With 1.1 billion parameters, this model marks a significant breakthrough in how robotics and autonomous systems interpret and interact with complex environments. The architecture underpinning LingBot-Vision relies on a vision transformer framework with a focus on boundary-centric feature extraction. This approach uses boundaries as a pre-training signal, enabling the model to perform on par with much larger models while maintaining a smaller computational footprint. Key technical features: boundary-centric feature extraction. This system enhances spatial perception accuracy by focusing on the delineation of objects within a scene, effectively capturing complex environmental features. Mask boundary modeling. During the training phase, this methodology leverages the boundaries of objects as a pivotal component, allowing the model to better distinguish and process spatial details. API compatibility. Integration with platforms like Hugging Face ensures ease of deployment and versatility, allowing developers to incorporate LingBot-Vision into various applications with minimal friction. Performance and deployment. LingBot-Vision's performance is reportedly comparable to much larger models, such as the 7B Dino V3. Its lightweight architecture makes it an appealing alternative for industries where computational efficiency is crucial, like robotics, autonomous vehicles, and augmented reality. Benchmarks indicate it holds its own in dense spatial tasks, offering significant value in a compact form. Practical steps for developers. For those interested in exploring LingBot-Vision: 1. Access the model. The model is available on huggingface.co/Robiant/LingBot-Vision-VT-small, a platform renowned for providing state-of-the-art AI resources. 2. Setup instructions. Detailed setup guidance can be found in its GitHub repository, streamlining the initialization process. 3. Testing scenarios. Developers can test the model's capabilities with real-world spatial perception scenarios using provided sample datasets, allowing for immediate feedback and optimization. Hashtag considerations and limitations. Despite its potential, LingBot-Vision requires careful consideration of hardware configurations to achieve optimal performance. As with any new technology, there's a necessity for independent validation of performance standards to ensure claims are met across diverse environments. Moreover, current documentation may lack comprehensive coverage of edge cases or nuanced failure modes, which could impact adoption in complex scenarios. Hashtag broader implications. LingBot-Vision offers a promising toolset for industries focused on robotics and autonomous systems, potentially paving the way for significant advancements in spatial perception technology. Its lightweight design, coupled with competitive capabilities, may revolutionize the deployment of real-time decision-making systems across diverse sectors, from manufacturing and logistics to consumer electronics and smart infrastructure. JetBrains is making notable strides with the launch of JetBrains AI for teams and organizations. This initiative integrates various AI tools within a cohesive framework to enhance software development collaboration across teams. A critical element of this launch is addressing the fragmented use of AI technologies currently prevalent in many organizations. JetBrains is adopting a vendor-agnostic approach, allowing teams to utilize their current AI tools while benefiting from improved integration and oversight. This platform's unified framework is designed to facilitate the seamless sharing of context and workflows, which is vital for efficient software development processes. Among the standout features are AI credits, which are pivotal for managing costs in a sustainable manner. These credits are expected to provide transparency in pricing, ensuring that organizations can predict and control their AI-related expenditures effectively. Although precise pricing models are yet to be disclosed, this initiative aims to enhance cost management across various teams. Another major component of the rollout is the integration with JetBrains Central. Launched in March 2026, JetBrains Central acts as a hub for monitoring and managing the tools, further refining organizational collaboration through enhanced analytics and governance structures. This integration optimizes resource allocation and project oversight, reducing administrative overhead and empowering teams to focus more on development rather than management hassles. Despite these advancements, there are challenges to address. The integration with existing AI tools could encounter hurdles, especially with legacy systems, potentially leading to resistance from developers familiar with their previous systems. Moreover, the actual impact on productivity and team collaboration needs rigorous assessment to validate these theoretical improvements. For teams eager to leverage these capabilities, a few practical steps include exploring that Brains AI overview, https://brains.com/AI, OpenA, for detailed feature descriptions, and consulting the official blog on the announcement, blog.jetbrains.com/blog 2026-07, JetBrains AI for teams and organizations, from fragmented AI usage to coordinated software development, UTeam source OpenA, to get a comprehensive understanding of potential applications. Additionally, setting up governance parameters via the AI Management Console is recommended to ensure robust oversight and effective utilization of the AI tools. In conclusion, JetBrains' push for a unified AI approach could revolutionize how teams engage in software development, offering substantial gains in efficiency, resource management, and perhaps even quicker time to market. The shift from isolated AI solutions to more integrated systems might redefine enterprise software development, potentially influencing organizational practices industry-wide. NVIDIA has introduced a tutorial focused on the Cosmos framework, encouraging the creation of mini-models that integrate text, audio, and visual modalities, specifically designed for those with limited hardware resources. This aligns with NVIDIA's broader Cosmos 3 initiative, aimed at enhancing AI's ability to process diverse data types. Cosmos 3 is built on an omnimodal mixture of transformers architecture. This architecture allows for the integration of various modalities within a single framework, making it an ideal resource for developing robust applications in fields like robotics and autonomous systems. With a staggering 16 billion parameters, Cosmos 3 Nano exemplifies NVIDIA's commitment to merging sophisticated AI functionality with accessible deployment. Key features of the framework include integration of diverse modalities: text, image, audio, within one architectural setup, utilizing advanced transformer mechanisms for versatile data processing. This approach benefits from the software's fine-tuning capabilities, which are supported by a managed environment using Kubernetes and SkyPilot, providing structured, efficient, and scalable modifications to suit specific needs. Technically, this is achieved by engaging with intricate fine-tuning procedures, such as those detailed in NVIDIA's supervised fine-tuning recipe. These procedures involve a coordinated use of checkpointing and auto-recovery options, ensuring process efficiency and continuity, particularly crucial in environments with restrictive hardware setups. The Cosmos 3 framework's performance is top-ranked in benchmark tests for multimodal generation tasks. It has achieved recognition for its ability to handle complex data interactions seamlessly, from interpreting visual to textual data to converting image data into video formats. However, the tutorial may encounter limitations depending on user hardware capabilities, a factor that could diversify model performance across different implementations. Practical steps to start harnessing this framework include engaging with the tutorial through the provided Colab link, delving into the comprehensive documentation available on NVIDIA's site, and experimenting with fine-tuning processes using guidance from SkyPilot examples. This structured approach not only aids understanding, but facilitates real-world application of the Cosmos framework without necessitating high-end hardware. Overall, NVIDIA's Cosmos framework tutorial is a significant stride in lowering the barrier for entry into multimodal AI development. By making the framework more accessible, NVIDIA is not only enhancing AI capabilities, but also setting the stage for accelerated innovation across various industries, including robotics and autonomous systems. Recent advancements in AI memory systems have brought to light four key architectures: Graphite, Hindsight, Mem0, and Supermemory. Each of these systems aims to bolster the capacity of AI agents and large language models, LLMs, by evolving their long-term memory capabilities, thus enhancing context-aware interactions and overall performance. Core architectures and their features. These memory systems employ unique approaches to improve interaction coherence and performance across various applications, offering solutions tailored for context-sensitive tasks. 1. Mem0 focuses on scalable long-term memory. It uses a memory-centric architecture that efficiently extracts and consolidates information, supporting coherence within AI interactions. Notably, Mem0 has achieved 67.13% accuracy on the Locomo benchmark with GPT-4o, highlighting its robust scalability and effectiveness. 2. Graphite employs a temporal knowledge graph framework that manages data temporally and contextually. This allows the system to dynamically adjust to changes over time, ensuring that information remains relevant and consistent with ongoing conversations. 3. Hindsight is structured into 4 distinct networks, optimizing retrieval and consolidation tasks. This architecture enables rapid updates, providing flexibility and adaptability in dynamic environments. With a remarkable score of 91.4% on long mem eval using Gemini 3 Pro, Hindsight showcases its exceptional retrieval capabilities. 4. Supermemory expands data ingestion capabilities by integrating diverse data sources. It processes over 100 billion tokens monthly with an 85.4% accuracy on long mem eval, facilitating enhanced interactions through detailed context graphs, supporting a wide range of applications. Challenges and trade-offs. Despite impressive metrics, there are challenges and trade-offs associated with these systems. Long-term performance and scalability. The performance and scalability of these memory systems in diverse applications remain areas of ongoing research. Differences in effectiveness can emerge depending on specific contexts, and this continues to be evaluated rigorously. Integration complexity. Some frameworks may require complex integration processes based on application-specific use cases, which could pose a barrier to adoption. Architectural debates. Ongoing debates regarding the optimal architecture for AI memory, whether graph-based or retrieval-augmented, persist, influencing decisions in system design and deployment. Practical steps and exploration. For those interested in exploring these systems further, here are practical steps. Review its detailed architecture on Hugging Face, huggingface.coapers 254.19413, OpenAI. Hindsight. Investigate its open source project and rapidly expanding capabilities on its project page, hindsightvectorize.io/blog 2026 fastest growing OSS AI memory, UTM source OpenAI. Graphite. Compare its framework to other systems like Membro via the Graffiti vs Mem comparison, respan.ai, Compareda. Implications and future outlook. These systems mark a significant leap in the capabilities of LLMs, paving the way for more contextually aware and personalized AI experiences. As these technologies continue to evolve, they are likely to redefine user expectations for real-time interactions with AI, enhancing efficiency, satisfaction, and competitive market positioning. As organizations integrate these frameworks, standards for AI performance in conversation will inevitably rise, potentially triggering advancements in related AI domains like automated reasoning and contextual understanding. Developers now have access to a new guide for creating a LangChain Deep Agents harness profile, specifically designed for NVIDIA's Nemotron 3 Ultra. Released in June 2026, the Nemotron 3 Ultra stands out as a 550 billion parameter mixture of experts model, demonstrating exceptional AI agent performance. This guide offers innovative strategies to enhance AI capabilities by focusing on harness engineering rather than undergoing traditional model fine-tuning processes, which can often be both costly and time-consuming. LangChain's agent engineering platform is a pivotal tool, with over 200 million monthly downloads, highlighting its utility in the AI community. The main focus of this approach is to customize harness profiles, allowing AI models to adapt seamlessly to specific workflows, thus streamlining development processes and significantly boosting efficiency. This form of customization is crucial for meeting enterprise needs, where adaptability and precision are key. Technical drill down. Several technical elements underpin the LangChain harness profile approach. 1. Harness customization. By utilizing the LangChain platform, developers can precisely tailor harness profiles to match specific tasks, thereby achieving enhanced accuracy and performance. 2. Iterative improvement loops. Employing iterative loops, the framework continuously refines agent performance. This involves cycles of evaluation, failure analysis, and harness adjustments, all automated via the Langsmith engine. 3. Automation and self-correction. The Langsmith engine automates the refinement of harness profiles, providing a self-correcting mechanism that reduces the risk of overfitting. This process ensures that adjustments are beneficial and robust over time. 4. Evaluation benchmarks. Performance is evaluated against set benchmarks, ensuring models are efficiently adapted without extensive retraining. Performance metrics. The guide details compelling performance results. The Nemotron 3 Ultra delivers a remarkable up to 5x faster inference compared to similar models, addressing efficiency demands. Additionally, operational costs for inference are reduced by an impressive 30%, offering significant financial savings for businesses. Practical steps to engage with the guide and leverage these improvements. Access the NVIDIA technical blog. Developer.nvidia.com/blog. Create a LangChain Deep Agents harness profile for NVIDIA Nemotron 3 Ultra to improve performance for a step-by-step guide. Utilize the Langsmith engine to facilitate automation during harness refinement, focusing on evaluation benchmarks to gauge model performance effectively. Trade-offs and uncertainties. Despite its potential, the long-term sustainability and generalization of these harness profiles across diverse applications remain uncertain. The method prioritizes environmental adaptation over constant model innovation, which could redefine AI engineering approaches, but also brings into question how these changes integrate with future model advancements. In conclusion, this guide marks a significant step in AI agent optimization, promoting a shift from traditional fine-tuning to harness engineering. As developers explore this novel approach, they may find new efficiencies and cost savings, potentially setting a new standard in AI agent development methodologies. Agentic AI is transforming the landscape of artificial intelligence with the introduction of autonomous agents capable of operating across complex systems. This development necessitates the creation of refined evaluation metrics and the establishment of robust safety standards that differ from traditional human-centered approaches. At the heart of this transformation is the concept of agent harnesses, structural mechanisms specifically designed to manage the operational intricacies of AI agents. These harnesses are critical for ensuring that AI systems perform effectively, safely, and reliably in dynamic and sometimes unpredictable environments. Technical components. Agent harnesses are designed with several technical components that work together to maintain control and order. Model encapsulation ensures that AI models process intent reception and context compilation securely, preventing unintended behaviors. Evaluation tools incorporate advanced observability features, change control measures, and incident response protocols to monitor agent actions closely and manage risks effectively. Governance protocols establish strict operational discipline during deployment to mitigate risks, including potential data privacy breaches and unexpected operational costs. Feedback loops. Integral to these harnesses, they continuously assess performance, allowing systems to self-correct and maintain safety and reliability. Industry impact. With a projected 60% of companies planning to deploy agentic AI by 2028, integrating agent harness frameworks can significantly enhance operational reliability and reduce costs. Properly implemented, these frameworks can mitigate risks associated with runaway loops or costly errors. However, they come with challenges. The over-permissiveness of operational environments can introduce security vulnerabilities, highlighting the need for careful design and implementation. Practical steps for organizations. Organizations looking to adapt to this new paradigm can take several concrete steps. Explore the Agent Ops framework. Detailed by Teradata in their guide, this framework offers structured safe deployment strategies, crucial for enterprises looking to harness AI's full potential while maintaining safety. Test evaluation methods utilize innovative methods from ContextOS to systematically assess AI agents, ensuring they meet both performance and safety criteria. Paradigm shift in AI deployment. Agent harnesses signify a monumental shift in AI deployment strategies, offering advancements in safety, operational efficiency, and potentially redefining industry standards. Implementing these systems effectively can lead to enhanced trust in AI technologies among consumers and businesses, empowering a new era of AI-driven innovation. As organizations navigate these changes, the role of reliable governance and meticulous system architecture becomes clearer. By embracing agent harnesses, industries can better manage the complex interplay between intelligence, autonomy, and control, ultimately paving the way for smarter and safer AI systems in the future. B2B sales training is undergoing a significant transformation, with AI role-play systems becoming an essential component. These sophisticated platforms offer scalable and interactive alternatives to conventional sales training methods, which traditionally include classroom learning, shadowing, and passive video modules. The main challenge of these traditional methods is their reliance on trainer availability and the inconsistency in feedback. In contrast, AI role-playing provides an environment where sales teams can engage in highly realistic and tailored scenarios. A key feature of AI role-play systems is their ability to simulate realistic sales interactions using adaptive machine learning algorithms. These algorithms dynamically adjust scenarios based on user responses, creating a unique experiential learning opportunity in each session. Moreover, immediate feedback is a cornerstone of these systems, significantly enhancing learning outcomes. By receiving real-time insights into their performance, sales representatives can refine their techniques rapidly, fostering a deeper understanding of effective sales tactics. Integration with customer relationship management (CRM) systems is another major advantage. This integration allows sales reps to access relevant client data, maintaining a seamless flow between training and real-world applications. Additionally, advanced analytics capabilities within AI platforms track performance metrics and skill development over time, providing invaluable data for both individual and organizational performance assessments. Empirical data highlights the efficiency of AI role-play systems. Some organizations report up to a 20% improvement in sales performance metrics after implementation. Furthermore, the onboarding process for new sales hires has been notably expedited, from an average of 6 months to just 3 months, thereby accelerating the time it takes for new employees to become fully productive members of the sales team. For businesses considering this transition, practical steps include exploring trial versions of AI platforms such as HighSpot and Atensi. Implementing a pilot program can facilitate immediate feedback and tangible results, guiding more comprehensive integration. Despite the promising outcomes, there are limitations and challenges to consider. The initial costs of implementing AI role-play solutions can be significant, potentially limiting access for smaller companies. While effective in simulating many aspects of sales interactions, AI systems may still struggle to replicate the nuanced human elements critical for closing deals. Concerns around data privacy, cost-effectiveness, and varying success across different industries remain areas for further exploration. The shift to AI role-play in sales training is not just about adopting new technology. It's about redefining the efficiency and effectiveness of sales teams in a highly competitive market. Organizations adopting these AI-driven training systems are likely to see not only improvements in individual and team performances, but also a marked enhancement in their overall competitiveness in the B2B sector. This approach represents a forward-thinking evolution in sales training methodologies, poised to set new standards in the industry. The software development landscape is undergoing a pivotal transformation with the introduction of Agentic Development Environments, ADEs. These environments mark an evolution from traditional integrated development environments, IDEs, to systems where autonomous AI agents manage a vast array of coding tasks. As traditional IDEs struggle to keep pace with modern demands, ADEs emerge as the new paradigm, showcasing a collaborative synergy between human developers and AI agents. Designed to facilitate the simultaneous coordination of multiple coding agents, ADEs are equipped with features such as agent orchestration and multi-threading capabilities. These enable autonomous AI to execute complex tasks efficiently, reducing manual intervention. Integration with version control systems such as Git worktrees is standard in ADEs. This allows for seamless project management, making it easier for developers to oversee large projects while AI agents handle subtasks like code inspections and pull requests. The promise of transitioning to ADEs includes substantial reductions in development time and labor costs. Although precise numerical benchmarks are yet to be fully established, the parallel execution of tasks by AI agents significantly enhances workflow efficiencies. However, this shift introduces significant security challenges. The rise of agentic swarms and their associated vulnerabilities, such as reverse shell exploits, highlight the pressing need for robust governance, compliance measures, and continuous security audits to safeguard organizational data and integrity. To effectively navigate these innovative environments, developers and organizations are encouraged to explore the following practical steps. Explore ADE documentation. Delve into the comprehensive documentation and tutorials provided by leading ADE platforms to understand the collaborative capabilities and technical nuances. Utilize Git worktrees. Implement sophisticated workflows using Git worktrees within an ADE setting to gain first-hand experience with advanced orchestration capabilities. Engage with the community. Participate in demos or webinars hosted by prominent ADE developers to grasp the practical applications and emerging security practices that ensure effective deployment. While ADEs offer an exciting new frontier in software development, the trade-offs and limitations must be considered. Transitioning from traditional IDEs may require extensive developer training to adapt to new workflows and technologies. Moreover, the inherent security risks posed by autonomous coding agents could potentially lead to the exposure of sensitive data if not properly managed. In summary, as software development continues to evolve, ADEs are poised at the forefront, presenting a compelling blend of increased efficiency and cutting-edge technological innovation. Nevertheless, achieving the delicate balance between harnessing these advantages and ensuring robust security remains a critical challenge for developers and organizations, emphasizing the need for ongoing research, adaptation, and vigilance in this rapidly advancing field. We've explored the latest advances in AI, from multimodal models to agentic environments, each offering exciting opportunities and challenges. Keep tuning in as we continue to bring you up to speed with the innovations shaping our world. Until next time, stay curious.